Ladies and gentlemen, thank you for standing by. Welcome to the Platform9 and SolidFire webinar. For today's presentation, all participants will be in a listen-only mode. Should you wish to ask a question during the presentation, please use the chat feature located in the lower left-hand corner of your screen. If you should need to reach an operator at any time, please press *0. As a reminder, this conference is being recorded today, October 20th, 2015. I would now like to hand the conference over to Kenneth Hoy from Platform. Thank you. Mr. Hoy, please begin.
Okay, thank you very much. Thank you everyone for joining our webinar today, this joint webinar between Platform9 and SolidFire. I want to start by making some introductions of the different presenters. So, let me advance the slide. Okay. Starting myself, my name is Kenneth Hoy. I am the Director of Technical Marketing at Platform9, and you can also find me on Twitter as you can see there. I'll hand it over to John and Aaron to introduce themselves. John?
Yeah, so my name is John Griffith. I'm a software engineer at SolidFire. You can see I have Twitter at JDG_8, and I'm always on Freenode at JGriffith. Aaron?
Yep. Hey, I'm Arun Sriraman. I work in Platform9 as a software engineer, and yeah, no Twitter.
Hey, thanks, John, and I'm looking forward to doing this webinar with you. So let me lay out a bit of an agenda today for what we want to talk about in this webinar. We talk about persisting data in the cloud with OpenStacks Cinder. Since we're not sure what the experience level of everyone on the call is on this webinar is, I'm going to do a very short introduction of what OpenStack is, how it started, what's intent. Then talk a bit about what OpenStacks Cinder is as a technology, and then we'll be reviewing some typical use cases for using Cinder with an OpenStack cloud. Then talk about how Platform9 and SolidFire in particular are partnering in a unique way to bring OpenStack and OpenStack Cinder in essence to the masses, and then end with a short demo to show you how the integration works. So let's talk a little bit about sort of the beginnings of OpenStack. We're going to just spend a few minutes on that. So in one sense, you could say OpenStack started with an email. In summer of 2010, a company called Rackspace, which at the time was primarily a server hosting company, was planning to create a public cloud that would be in essence allowed to compete with Amazon Web Services. But the unique thing they wanted to do with that cloud was they were planning to open source the platform. And they found out along the way that NASA was actually creating their own cloud platform as a private cloud technology. And so an executive at Rackspace, Jim Curry, reached out to Chris Kemp, who was a CTO at NASA, in charge of the Nebula project, and suggested the idea that Rackspace and NASA could work together to open source this cloud platform. And that's essentially how OpenStack started, as an open source project designed to help both service providers and end user customers create a cloud platform similar to what you'd find with Amazon Web Services. And from that fairly humble beginning of just those two companies, and a few developers, it has now grown in these 5 years to be one of the largest and fastest growing open source projects in the world. As you can see, with over 30,000 people in the community, spanning over 170 countries, with 20 million lines of code. So there's now a full-blown project with a full-blown community that can around it to help develop it and advance it. But exactly what is OpenStack? And let me briefly talk about that. So in essence, OpenStack is not a virtualization technology per se. For example, VMware would be considered a virtualization technology. It's also not a networking technology like the Cisco, and it's also not a storage technology like SolidFire. But in fact, what it is actually a management platform that sits on top of all those various resources in your data center, and essentially allows you as an administrator to automate the pooling and then presentation of those resources to end users. And the other key part of OpenStack is a self-service platform for users. So the idea being that instead of having to go through an admin as you traditionally do, in order to access these traditional data center resources, an end user, typically a developer, can actually create those resources himself, him or herself. And it does that by pulling together various what we call open source projects. Each project is related to a specific aspect of cloud computing. For example, Neutron is a project that brings together various networking technologies and apply them to a cloud platform. Nova is a technology that works with various compute technologies like hypervisors and containers. And Cinder is as we'll talk about a bit more later in detail, is the block storage project that enables a user of OpenStack to be able to provision and then manage storage resources on his own without requiring the intervention of an administrator. And the key to that is being able to deliver these data center resources in a self-service manner at speed and at scale. So the key here is, for example, that like the public cloud that you find in Amazon Web Services and Rackspace today, we want developers to be able to quickly provision resources, spin things up, spin things down, and then so that they can spin up new projects, end those projects, and they'll experiment in such a way that they are able to bring value to their businesses much more quickly than ever before. So that's really an intent of OpenStack, right? To take these traditional data center resources, present them in a new way to allow developers to have control and to be able to manage their own resources. And this ecosystem that has gone ahead and created OpenStack has also created a number of ways for which OpenStack can be used by end users. So the three primary ways or consumption models. One is obviously the public cloud, which is with the intent of Rackspace, right, to create an open public cloud based on OpenStack. And there are a couple of companies today that are offering OpenStack-based public clouds. Private cloud distribution is another consumption model, and that's essentially what NASA was interested in when they created Nebula, and then went into partnership with Rackspace to open source their code, is to create a public cloud type of environment with the same type of self-service and scale, but inside their own data centers, operated by NASA personnel. And now there are a number of vendors who are offering distributions, ways for end users to also be able to manage their own private cloud. And then the third consumption model that's beginning to get a lot of traction is what we call private cloud as service, which in a sense is a hybrid between the two models, in that these are solutions around OpenStack where the end user consumes OpenStack as though it was a public cloud, except that it's a single tenant model, and the operations of that cloud is not done by the end user, but actually by some service provider. And again, there are a couple of companies that are doing that. And that model, because it's single tenant, can sometimes be hosted off premises, but in many cases are also hosted on premises or some hybrid model that in between, which is what Platform9 does. And if you look at that space, it is a thriving ecosystem with many partners that are delivering OpenStack in these various consumption models, and you see that here in the public cloud space, private cloud distribution, and also as private cloud service. And all these vendors can be found in the OpenStack org website under their marketplace page. So let's stop for a moment just to see if there are any questions about OpenStack in general. If not, I'm looking on chat. If not, I'll go ahead. Let's move ahead and talk a bit about OpenStack Cinder in particular. So what is OpenStack Cinder? So I mentioned previously that OpenStack itself is made up of various projects, each project focusing on a specific component of technology of cloud computing. So Cinder is the project that's focused around block storage. And you may be wondering why that's important. So one of the tenets, by default, when you create a cloud instance or virtual machine in OpenStack, the assumption is that the storage that that cloud instance has is what we call ephemeral. In other words, when as a user you delete that cloud instance, all the data that sits with that instance is automatically purged. And that is actually a useful paradigm for a number of applications that run in the cloud. But also obviously there are other use cases and workloads where some level of persistence is required, right? Where you don't want the data to be purged or deleted when you destroy an instance. And John's going to talk a bit about what some of those use cases are. But for now, just know that the way that OpenStack provides this persistent storage that you can attach to an instance and then detach and plug to another instance, it's what OpenStack Cinder is trying to do. And architecturally, the way Cinder works is there is a number of services called the Cinder service that basically manages the storage volume that's presented to it. That storage volume can be presented through the server storage, but as we'll talk about today, can be presented through an enterprise array such as SolidFire. And that storage gets presented to an instance that could be sitting on a KVM hypervisor or a VMware hypervisor or even a container, or Docker container, and basically provides this persistent storage that continues on even after the VM or the container is no longer needed. So in summary of talking about OpenStack Cinder in this overview, it basically Cinder allows you a way to basically scale your capacity, but particularly when you're using an enterprise array like SolidFire, where you can scale to terabytes of data using a few nodes as opposed to using a server storage where you're limited by how much hard drive you can pop into that server. Also, OpenStack Cinder, working with enterprise storage arrays, also provides you an HA, which some workloads need, where the application needs the storage to stay up even when there's some kind of error in the cloud. And one of the neat things about the way Cinder has progressed, and again, John will talk more about this, is whereas initially Cinder's block storage was basically, the best analogy I would say is basically was dumb storage that you would just present and plug into a VM. With the progress of Cinder, with using storage arrays like SolidFire, we're now able to actually deliver these new enhanced features through Cinder to the virtual machine, so that you have things like quality of service, which you can then assign to specific workloads that you're running in your OpenStack cloud. And then finally, one other benefit of Cinder is that as a user, you can now repurpose storage that you may have been running in some other reason or other platforms, and now you can repurpose that to be used in your OpenStack cloud. So you don't have to buy a brand new storage system. So that's a kind of a quick overview of OpenStack Cinder. Again, I'll pause for a minute just to see if there are any questions about Cinder itself or about OpenStack, and then I'll pass the presentation over to John Griffith. Okay. I'll get sorry. Looks like we're actually taking questions at the end, so sorry about that. All right. So at this point, we're going to talk about some of the use cases, and I'm going to turn it over to John so he can walk through what use cases they're seeing with SolidFire today.
Cool. Thanks, Ken. Hi, everyone. So my name is John Griffith, and I want to talk a little bit about some of the Cinder use cases with OpenStack and what we're seeing in terms of adoption and what a lot of people are doing. So first, to kind of recap a little bit, what Ken just went through and described, the easiest way to think of this is basically what Cinder is going to give you is an automated way to basically plug in and plug out hard drives into your system. That's really the simplest way to look at it. You're basically using a massive thumb drive with all sorts of great capabilities and features and functionality that you don't need a storage admin to do everything anymore. So now you can do all this self-serve and do it on your own. Cinder is block storage. So the key there is it's not an object storage. It's not your low change rate content, not your blobs, not your images or music files or anything like that. This is what you want to use for your traditional storage like you use a disk for. It's what you put a file system on. It's what you run your apps off of, etc. The best analogy that you can really come up with, as with a lot of things in OpenStack, is you can find an AWS analogy. For Cinder, the AWS analogy is EBS, your elastic block storage. So the key to all of this, though, and what makes it so cool, is the difference now is instead of having a storage admin and certain storage setup and requesting volumes and adding them or adding disks, is now with Cinder, it scales, it's all automated, and it's completely self-service, which is totally on-demand storage, which is the big win. So out of all the use cases, we talk a lot about things like, running databases inside of OpenStack clouds, running different applications, things like that. But really the most popular thing that it all kind of boils down to in the early adopters of the cloud tend to be software developers. And the reason for that is because development is moving faster and faster. Developers need infrastructure resources, and quite frankly, IT groups can't keep up with them, right? Because things are moving so fast. There's so many developers. There's so much going on that you just can't have an IT group that's able to move fast enough and manage all of this for them. So the idea is that since the traditional request and provision process is too slow, the old submit a ticket, IT gets back to you, maybe you get what you want, et cetera, that's too slow. So what we want to do is we want to make it self-service and we want to make it faster. So everybody wants to move faster these days. So let's kind of take an example here. So if I am a developer and I've got an app that I'm writing that uses, MongoDB, and I'm doing some things with CentOS, the things that I need to think about is, okay, first of all, I need a system because I want to test this out. I want to test this idea that I have out. So I need a system for a day or so. I'm not sure, as I experiment, I may need more storage, less storage. I don't really know. I'm not sure what my memory requirements are going to be. And I'm not sure if I'm even on the right platform. I might want to use something else. So I need to kind of start gathering all this data and testing all these different scenarios. Now, in order to do that, what's going to happen is I'm going to have to try and guess. And of course, I'm going to guess on the high side, right? And then we're going to underestimate. And I'm going to submit a request to the IT group. And then I'm going to have to wait for them to act on it. And usually that takes a while. That could take a few days. And they may come back and not have any resources and just say, sorry, you're out of luck, maybe next week. Or they may come back and say, well, I can't give you that CentOS box, but here's a Windows server. It's the same thing, right? You can do whatever you need to do with it, right? That just flat out doesn't work. So the result is you get developers that are unhappy. They're not productive. They're not moving as quickly as they could. And what we were seeing, years ago, and the reason OpenStack kind of started and why AWS is such a popular thing, is developers were saying, hey, I can't, I don't want to work like this. This takes too long. And they were using their personal credit cards to just go out to AWS and get the resources they needed, run their experiments, run their tests there, and then come back and finish up the job in the office, right? So now with Platform9 and SolidFire, as long as you have quota in your cloud, so OpenStack has quarters. You can manage everything from the storage, the networking, the compute, everything self-service. So I spin up an instance, I load my software, hack it some code, maybe figure out, hey, I need more performance storage. So with SolidFire, you can go and you can adjust you can retype the volume to have higher performance and higher QoS settings. You can go ahead and snapshot everything so that, hey, this is an interesting stopping point for me, and I'm gonna save this image, and then I'm gonna go off and I'm gonna modify some things and try it out, and then you can come back to that snapshot later. So you can do all of this self-serve on demand, which is the big difference. So now you don't have to go through and find the storage admin and have him or her go through and do all this stuff for you. So you do all these things, you come up with some new ideas, and you think, hey, maybe my design has changed. Maybe I could actually try this with a different approach and use MySQL or traditional database. So I'm going to spin up a whole other platform and duplicate a lot of this stuff using clones or snapshots or whatever you might want, and experiment and try it out. So you hack some more code and you figure out, oh, hey, this is even better. So now you continue and you write your app. So the app's looking good. Next step, hey, I should probably test this in a clean environment, make sure everything works and it's reproducible. So you spin up yet another instance. Again, as long as you have quota, you can just keep doing all this on demand and on the fly. Figure out some things. You need to run a different distribution of Linux maybe. Try that, run some tests, on and on. Just keep repeating. The beauty of all this is you're doing this all on the fly. You don't have to stop and wait for request fulfillment or anything else as you go. So in the time that it might have taken me before in the old model to actually just get my initial resource request, I tested my initial design in multiple configurations. I tried a completely new design in parallel and figured out that it was better. I finished my application, tested it on multiple platforms, and I released an app that hopefully makes my company billions and billions of dollars. And the result, everybody's happy. Everybody wins. So anybody have it? We're going to queue up the questions. We'll make sure we save some time. It looks like we've got a couple in there. If you have any on that section, let me make sure you post them to the questions section so that we can allot some time at the end and make sure we get them answered. And with that, I'm going to go over and talk a little bit more about the bigger picture of Platform9 and SolidFire. And to do that, I'm going to turn this back over to Ken for a minute.
Great, thanks, Sean. So you know, one of the slides that I presented, I talked about the fact that there are a number of consumption models for OpenStack today. Various, each have various pros and cons, I guess. One of the models that, as I mentioned, is taken off quite well is the cloud as a service model. And that's something that Platform9, as a company, we're very much invested in as the right model for how to deploy OpenStack today. So I want to talk a bit about what Platform9 is, and how we are making OpenStack an easier solution, perhaps the easiest way to deploy OpenStack today, and then talk specifically about how we are integrating with SolidFire to bring all the great benefits that John just talked about with Cinder, especially on top of SolidFire to the masses. So a couple of slides to talk about what Platform9 is and how we deploy OpenStack. So the best way to think about Platform9 is that we are a managed OpenStack offering. And the way we do that, we actually have a fairly unique model in that we actually believe in a kind of a share model for OpenStack, which means that we basically take the OpenStack control services, typically what they call, they're typically running on servers they call OpenStack controllers. The code that's actually pulling the resources and automating the self-service. And we actually run that in our off-premises, but we actually connect back into a customer's environment to allow them to use their existing resources and to use things like SolidFire as their back-end storage. So the key to that is we basically take away all the difficulties that comes in managing a cloud platform like OpenStack. We remove that from the concerns of our customers and basically have our customers focus on the things that they do really well, which is managing their data center and managing their hypervisors and their storage and networking platforms. And also by doing this, as you can see here, all the workload and data that customers many times don't want running on a public cloud, and it actually stays within the customer's data center on their premises and never goes out, even though management is actually sitting outside the data center. And we're able to do that for both KVM and VMware, and soon for Docker as well. And then the value prop that comes with that is essentially from a cloud management perspective, Platform9 basically takes full responsibility for managing for that lifecycle management. So we are responsible for the SLA to make sure that the cloud platform is always available for your developers and end users to use. We make sure that we're monitoring the health of that environment, that we actually do the upgrades, the troubleshooting, and the scaling. So these are things that traditionally have been barriers for adoption for OpenStack, because it is as you have seen throughout this webinar, a fairly large and complex open source project. And it's difficult many times for you end users to have the personnel to be able to manage that environment, as well as what's already running the infrastructure. So by taking those concerns away, we enable customers to do what they do best, while we are essentially helping them lay on this new self-service capability for the infrastructure. So at this point, I'm going to turn this over to John again, just for him to talk a little bit more about SolidFire and OpenStack, and then I will come back on and talk about how we're integrating with SolidFire.
Thanks, Ken. Yeah, so from a SolidFire perspective, we have been involved in OpenStack for a little over 4 years now. And the way we looked at things with OpenStack was that it was definitely the future of computing, of data centers and IT, and it's where everything was going. And our investment was not quite the traditional investment. A lot of folks invested in OpenStack by just providing a driver or a plugin and making sure that they actually worked so that they had a story. And we took a different approach and thought that we would rather invest in OpenStack and make OpenStack better. So we actually led the efforts to create the Cinder project, the block storage project inside of OpenStack, and focused really primarily on that at first, and kind of built that up and turned that into something that was a usable and flexible piece of infrastructure. So that was kind of our big focus. And the result is we have a platform in SolidFire that is actually a perfect fit for OpenStack. It's fully automated. Everything that you do on a SolidFire cluster you're capable of doing that through our API that uses JSON RPC. So there's no hidden management consoles, there's no hidden management UIs or anything like that. Everything can be automated and everything can be done through the API. In addition to that, one of the key tenets for us is the granularity of resources for us is actually the volume itself. So you don't have things like pools or shelves or anything like that you have to deal with and try and maintain and balance. You need a volume, you get a volume. And that's pretty much as simple as you can get when you're dealing with storage. But the most important thing is what we did is we actually decoupled your performance and your capacity. So now what you can do is you can actually treat those as two separate pools of resources. Traditional storage systems, what you have to do if you want higher performance, you have to actually increase your capacity and under-provision that capacity in order to guarantee higher performance. What we've done is we've actually separated those two interests, and we give you two separate pools that act completely independent. So you can go ahead and specify the exact IOPS that you want to guarantee to your customers or your cloud users, and you can also go ahead and set up the capacity independently. So they're two independent entities. Of course, with SolidFire, you get the full integration into OpenStack. So all of the Cinder API calls are supported. Setting and maintaining QoS levels, you get a max, min, and burst performance level that you can set based on IOPS. You can, of course, do snapshot, cloning, rollbacks, boot from image, everything else. So it really gives you a full-featured story in terms of your OpenStack storage. needs. In addition to that, we're also going to give you the ability to do bootable volumes off of SolidFire and things like that. And we're going to let you scale out. So it's not a monolithic single point of failure or dual controller or anything like that. It's a true scale out solution. You can start with as little as 4 nodes and grow to as many as 50. It just doesn't matter. Or do multiple clusters, etc. And then I will turn this slide back over to Ken and let him talk a little bit about our integration with each other.
Sure. Sure. Thanks, John. So I want to pull this together a little bit. So you've kind of heard about Platform9 and what I've said is the value of our solution. You've heard John talk about SolidFire and the value of that SolidFire solution. You can see there's some common themes around automation, around ease of use, around being able to set up and run fairly quickly and easily. So we thought it was a natural fit for our two technologies to come together. And so what we've done essentially is we've figured out a way to kind of take our unique cloud management as a service that's managed offsite but delivered as a SaaS service to a customer's data center. We figure out a way to integrate that still with SolidFire in such a way that that we can take a user's infrastructure, have them attach a SolidFire array on it, and still be able to use Platform9 OpenStack to manage that storage array, giving you block storage to your OpenStack cloud. And a lot of that integration beyond just being able to create that separation. So again, we are basically responsible for the sender services. Customers don't have to take responsibility for that. They just have to, again, focus on managing their infrastructure, including the SolidFire array, and we manage the integration with OpenStack. Beyond that, we also wanted to make it as easy as possible so that for you to be able to use the same dashboard that you would be using to manage your cloud instance resources or your network resources, to also be able to use that to configure and manage your storage resources. And that kind of brings us to the next, kind of the final part of our webinar, which is Aaron and John's going to talk through a live demo we're doing around the SolidFire integration into Platform9 OpenStack. So do you want to, I'll let you give that over to you.
Yeah. Thanks, Ken. So yeah, I'll share my screen now and we'll go ahead with the demo. So what you see here is the Platform9 Managed OpenStack Controllers dashboard. It gives you all kind of statistics as to what you have in your cloud. If you look at the infrastructure tab on the left, you can see that you have 3 hypervisors in your cloud, and one of the hypervisors is configured with image and block storage. So how you make Cinder work with SolidFire backend is as easy as just selecting the driver type and providing the information that is required for SolidFire, simple as username, password, and the IP that you pretty much reach to the SolidFire controller. So once you provide this and authorize, you're going to have a hypervisor running Cinder on the back end, which talks to SolidFire devices. So let me go ahead and quickly show you some stuff. So I go to volume and snapshots. You can see that there are no volumes. So what I'm going to do here is going to create a volume which is going to go on to the SolidFire controller. I can create volumes in various ways, as John mentioned. So what I'm going to show today is creating a volume from a glance image or an image that you already have. It could be an ISO or an image or a QPOW image. So this is a bootable image, Cirrus image. So when I create a volume out of this, it's going to be bootable. And then, so what that essentially means is you can bring up a VM without an ephemeral disk, but using volume, which is on SolidFire. And that's going to persist after the VM goes away. So as you can see, the volume is being created on the SolidFire device, and it's already done. But that's how fast SolidFire is. I click on the edit button, you can see an ID here. That's the OpenStack generated UUID for this specific volume. And if you look at the SolidFire console, I'm sure John will talk more about it, but this is the same UUID that you can see, and a 1 GB volume has been created. So now let's quickly go ahead and spin up a VM out of this particular volume that we create. So this is the volume that we created. I will go ahead and very quickly so there you go. A new instance is being spun up with the volume that got created on SolidFire. And this is a volume that's going to be used as your disk, which is going to have all your partition information. So it's already up. We'll go into it, and you can look at the console. You can see that the operating system is booting up. This is a Cirrus image, so it's comparatively small. You can boot up Ubuntu, CentOS, or Windows, whatever you like.
That's great, Aaron.
So, John, you can go ahead, and when it's going to come up, you can probably.
Yeah, I just wanted to add a couple of things that are going on in the background. Aaron pointed out too. One thing is in our integration for OpenStack, one of the things that's kind of useful is we have multi-tenancy on the SolidFire cluster as well. And what Aaron was pointed out was we actually do a one-to-one mapping between the OpenStack tenant and an account on the SolidFire cluster. So you actually have a tenant ID that matches the OpenStack tenant ID. So it's really easy to go ahead and segregate things and get an understanding of where things are at. In addition, we also have that one-to-one mapping for the volumes so that the OpenStack's UUID of the volume is also the same ID that shows up on the SolidFire cluster for the volume as well. So those are pretty important things. As you can see now, we've got this instance that Aaron created and booted up for us on the volume. The thing that's really cool about this is now you can snapshot that. You can make it a template and clone it multiple times and make all of those things will be really, really fast. And we'll use inline deduplication and compression and everything to make it efficient. So if you clone this 100 times, you're virtually using no new space. So those are some key points just real quick to kind of run through and keep in mind. Definitely more of a deep dive, but.
So to add to that, to what John was saying and going with the demo. So what I did here is create a simple file on the volume or in the virtual machine. Now what I'm going to do is go ahead and remove this virtual machine completely. So as you remember, I created this virtual machine from the volume that we created on SolidFire. So the volume is still going to persist on SolidFire. And if you look at the volume and snapshots, it's back to available. So now what I'm going to do is attach that particular volume to another VM that I have. And it should have already been attached. Yes, it's attached. So you can also see where it has been mounted as inside the particular guest or VM. So we go into that particular VM now, and you should be able to see that file which says created on VM1. So there is a VDB and VDB1. That's the file system that the Cirrus volume has internally. So what I'm going to do is I'm going to do a mount. I'm just mounting VDB1 to the directory created at volume. So you can see that the entire file system is there. So let's go into home, Cirrus. You can see that the file that says creating file from VM1 is here inside this. So what it really means is the volume that was used to create the previous VM, and then whatever changes you do there, it persists on SolidFire, and then you can use this volume to attach it to another VM, and you can see that the files here already. So other than this, you can do things like snapshotting the volume that John spoke about, and you can upload or create an image out of this volume, and then use that image as a glance image to create more VMs. let me hand over to John after this.
Thanks, Aaron. That was great. I think at this point we're ready to do some Q&A if anybody has any questions. It looks like we've got a few questions in the queue here. I'll go ahead and take this first one. The first question was, are there any issues with latency if OpenStack is managing resources that are physically located in various offices within a global organization, i.e. between the US and India? So that's an interesting question. Typically, especially as it pertains to your block storage in Cinder, what you would actually do is you would have a OpenStack deployment in each of those geolocations. And so the people in the US would use the location or availability zone in the US, while the ones in India would use that one. It is possible to do things with SolidFire like replication and things like that between data centers. Between locations like US and India, you're definitely going to have latency issues and things like that you have to be concerned with, for sure. But there are ways to do that and mirror the clouds between each other.
Okay. Thanks, John. So I think the next set of questions is kind of Platform 9 specific. I'll address those. So is there any advantage to the way Platform deploys upgrades? And does, I guess, I'll rephrase this, does config management or automation tools like Ansible provide the same advantage? So I think, let me address the first one. So I think the advantage that Platform 9 has in terms of the way we do upgrades is that first and foremost, is because it's a managed service, customers don't actually have to do the upgrades themselves. We actually handle that. And because we're running off-prem, there are some things we've been able to do that enable us to actually do these upgrades with almost little to almost no downtime at all. In fact, typically how an upgrade's done with Platform 9, for Platform 9 customers, is they'll get an email saying that there's a new version of Platform 9 OpenStack that's available. We would like to take maybe 30 minutes to an hour to do the upgrade, and then we basically ask them, are we planning to upgrade this time? Is that okay? And if the customer says yes, we go ahead and do that upgrade. And typically the upgrade doesn't actually impact running workload. It only impacts the OpenStack services and the ability for the customer to spin up new instances. But we do all that behind the scenes using technologies we developed. And so in many cases, in fact, customers see no downtime at all in their existing environment and only lose capacity to manage that environment for maybe 15 minutes to half an hour. All that, and again, if a customer, kind of answered another question related to that, is if a customer tells us for whatever reason they, maybe because they have a maintenance window scheduled at the keep and they say they can't do upgrades, we don't force the upgrade. Essentially, they can work with a Platform 9 engineer to schedule the upgrade for another time. So, and then there's another question: is Platform 9 fully automated? So, I guess it depends on what the question is. What is meant by that question? It's fully automated from the user perspective. It's fully automated in the sense of the OpenStack itself offers full automation for spinning up the resources. So customers and users, in fact, can create new resources without having to have an admin do that work for them. So again, that speaks to the self-service and agility that both John and I have talked about. And then in terms of operationally, I guess, running Platform 9, that's all being done by Platform 9 engineers, and we have tools that we use to automate much of that process. So from a customer standpoint, there is no operation, no burden to managing OpenStack control services. The only thing they have to manage really is the underlying infrastructure, everything from the hypervisor down through the hardware. And they're free to use any tools that they may be currently using or want to adopt. like Ansible, for example, to automate that process as well. And we will work with those tools to automate as much of that the private cloud as possible. Hopefully that answers that question. Let's see, are there any others? Okay. Doesn't look like it. So at this point, I think we're actually up to about on time. So I want to, I'll turn this back over to the operator. But for now, I want to thank everyone for being on this webinar. Thank you, John and Aaron, for participating, helping, and if you have any questions, further questions, I would encourage you to reach out to Platform9 and or SolidFire, and we'll be happy to work together to help you with your private cloud deployment. Thank you.
Thank you, everyone. Thank you, Ken.
Ladies and gentlemen, that does conclude today's webinar. We thank you for your participation and ask that you please disconnect your lines at this time.